So, hello and welcome to a new lecture on statistics, where this time we are going to introduce the cumulative density function. So, what is the cumulative density functions? Cumulative basically stands for summing up or adding up different values one to another, and density here is basically stands for probability, and the result will be a function. So, in order to get started, we are going to use one of the examples that was already introduced in some of the previous lectures, namely the one of the flip of a coin 2 times. So basically the different results are summarized here in this table. We have the different elements here, heads, 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 tails, tails, heads, or 2 times tails, with associated random variables x equals 0 for 0 times tails, x equals 1 for 1 time tails, x equals 2 for 2 time tails, with associated probabilities p of x equals 0, so 1/4, p of x equals 1, 2/4 or 1/2, and p of x equals 2, 1/4. So basically we have all the information contained within this table, and with this we are going to work out the cumulative density function. But before we start, we first write down the formal definition of the cumulative density function. So cumulative density function is actually a function f of x equals some value n. And as I already mentioned, basically we are going to sum up the different probabilities. So it's a sum going from some value k equals 0 to some value n of the different densities or probabilities. So that's basically the formal definition of the cumulative density function. Now we are using this example here, the flip of a coin, 2 times, and are going to have a closer look to the different values of n contained here. So basically we have n smaller than 0, but we actually have no value for n smaller than 0, so the associated cumulative density function of x smaller than 0 is 0, because there's no value for it. Then we have n equals 0. This is the first value that is actually contained within our table. So f of x equals 0 equals the probability p of x equals 0. P of x equals 0 is 1/4. So we have 1/4 here. Then we have as value n equals 1. So f of x equals 1 equals the sum going from k equals 0 to 1 this time. So basically we have p of x equals 0 plus p of x equals 1 equals 1/4 plus 2/4. So 1/4 plus 2/4 equals 3/4. And the last case is n of x equals 2. So f of x equals 2. So basically we have to sum up this time from k going to 0 up to 2. So p of x equals 2 plus p of x equals 1 plus p of x equals 2. And this time we should recover 1, because we are taking all the 3 random variables that represent the different elements contained within this sample space. So let's have a closer look. P of x equals 0, 1/4, plus p of x equals 1, 2/4, plus p of x equals 2, 2/4. And indeed, we recover the number 1 here for the total probability. So with this, we are now ready to draw the cumulative density function, which is basically a plot that has 2 axes, an y-axis and an x-axis. On the x-axis we have the random variables x, and on the y-axis, of course, the cumulative density function. So we are going to introduce the random variables first. So we have 3 different values. We have x equals 0, x equals 1, and x equals 2. And at the level of the probabilities, we have 1/4 for x equals 0. We have 2/4 for x equals 1, 3/4 here, and the total probability 1. So we saw that for n being smaller than 0, our cumulative density function is 0. So we are basically somewhere here. And then suddenly, at the level of the random variable x equals 0, our cumulative density function performs a step. So going from probability 0 up to 1/4. So basically we end up here. So this value is excluded and we end up here. From this then we are going up to the next random variable. There is no change in probability. And this time we are making a jump going from yes, so basically we have this here, and then this value is again excluded, and we are performing a jump here at the level of x equals 1. X equals 1 here. We end up at 3/4, so basically here. So this value is included, but this one is excluded. So this is the jump I mentioned. And then we are having a straight line again, because there is no change. And then suddenly at the value x equals 2, we are having again a new jump. So this value is excluded here. And we jump up to the total probability 1. And from here on, there is no change again, because there is no additional random variable. So basically, we see that a cumulative density function is actually the sum of the different associated probabilities. If you have questions, please leave a comment in the comment section below, and looking forward to see you again in the next lecture on statistics.